Hello everyone, my name is Mohamed Soliman. I'm a postdoc at the University of Groningen. Me, Matthias Galster from the University of Canterbury in New Zealand and Paris Avgeriou in the University of Groningen, we have conducted an exploratory study to explore architectural knowledge in issue tracking systems. So let's start. Architectural design decision is challenging and involves lots to consider. First, the architect needs to consider the decision factors like functional requirements and quality attributes, such as performance or security. He also needs to consider constraints imposed by existing systems, such as quality issues. Based on these inputs, the architect proposed certain alternative architecture solutions, like component designs or applying architectural tactics or patterns. Finally, the architect selects one architecture solution after analyzing the benefits and drawbacks of the alternative solutions, or by making assumptions in case information are unknown to the architect, or making trade-offs between different quality attributes. We refer to all these concepts with the term architecture knowledge concepts, which support the architect make the architecture design decision. Capturing architecture knowledge is challenging. Architecture knowledge is mostly tacit and just resides in the brain of software engineers. Researchers have tried to manually capture this knowledge by filling architecture knowledge repositories to share and reuse this architecture knowledge among software engineers. However, the amount of effort to manually populate architecture knowledge repositories is a bottleneck for capturing architecture knowledge. Therefore, researchers have started to explore architecture knowledge in different other sources. One source is the issue tracking systems, which provides a mechanism for software engineers to post issues such as adding new features, bugs, or refactorings. It also provides a means for communication between software engineers. Recent research efforts identified certain types of issues which discuss architectural problems, which we refer to here as architectural issues. However, it's unknown how software engineers make design decisions in issue trackers and which architecture knowledge concepts are used for making design decisions. Therefore, our main goal from this paper is to explore architecture knowledge concepts in the architectural issues, which is an important step before capturing architecture knowledge from issue trackers. To explore architectural knowledge in architectural issues, we need to find architectural issues first. However, finding architectural issues is a very challenging task. This is because architectural issues are not separately classified by developers, and they present a minority of issues within a big number of issues. In this paper, we followed a bottom-up approach to find architecture issues. In this way, we analyze source code repositories for projects to identify certain architectural commits, where each commit is associated with an issue using an issue ID in its commit messages. To achieve this, we performed static source code analysis for each commit to identify architectural components and their dependencies. We then compare the components model between each consecutive commit to identify commits which involve architectural changes. For example, in this figure here, the first commit added a new component and a dependency to the source code. Therefore, we measure the architectural changes for each commit in order to identify the commits with the most architectural code changes. And accordingly, from this list, we selected a sample of architectural issues which has the most architectural code changes. To analyze architectural issues for architectural knowledge, we followed a deductive content analysis process in which we annotated sentences in architectural issues. I will give here an example for the annotations. This is an architectural issue in Apache Tayo, one of our analyzed projects. For this sentence, in the current implementation, the resource management of Tayo is tightly coupled to Hadoop Yarn. We annotated this as an existing system quality issue. And for this sentence, Hadoop Yarn has emerged and a nice resource manager for large clusters, but Yarn is not the best choice for low latency query execution. We annotated this as benefits and drawbacks. We have also annotated the PDF attachments which contain architectural descriptions. For example, here in this issue, the developers shared an architecture model and a description about this architecture model, in which we annotate this as architecture configurations. Finally, we have also annotated the comments with the discussions between software developers. So, for example, here the sentence will support the standby mode for low latency. We annotated this as an architectural tactic. In total, we have annotated 98 architectural issues and over nearly 4,000 annotations. Based on these annotations, we answered our research questions. Concerned with architectural knowledge concepts which are shared in architectural issues. We can see here that the majority of architectural knowledge concepts are about architectural solutions and the rationale, while decision factors are less shared in architectural issues. If we look at architectural solutions, we will see that most of them are about describing architecture configuration or describing the behavior of a certain architectural component, while solutions like patterns and tactics are not commonly mentioned in architectural issues. If we look at the rationale of solutions, we will see that most of them are about benefits and drawbacks among solutions or assumptions. Other rational concepts, such as trade-offs or risks, are not commonly shared in architectural issues. Finally, by looking at decision factors, you can see that most of the factors are about existing system quality or architecture, while there are less discussions about requirements, such as quality attributes. We have also analyzed the size of architectural knowledge concepts in terms of the number of words in each annotation. We can see here that architectural configurations have the biggest size, and this means that developers describe the relationship between architectural components extensively. When comparing the architectural solutions with the rationale of decisions, we will find that the rationale of decisions are shorter in terms of the number of words than the describing the solutions. Thus, developers do not elaborate much on the rationale of making a decision. Finally, by looking at the decision factors, we can see that existing system architecture and quality have a comparable size to the rationale of the solutions, while requirements such as quality attributes have the shortest and the least presence in architectural issues. From this, we can conclude that architectural issues are suitable for capturing architectural knowledge on architectural solutions and the rationale of decisions, but it has less amount of architectural knowledge regarding requirements analysis. These knowledge on requirements might be shared somewhere else in, for example, in mailing list or during virtual meetings between developers. In the second question, we have analyzed the co-occurrences between architectural knowledge concepts in both issue descriptions and also comments. In issue description, if we look at the architectural solutions, we can see that both component behavior and architecture configuration are significantly co-occur with each other, while architecture tactics only occur with component behavior. Thus, tactics are only discussed in the scope of a single architecture component. When looking at the rationale of solution, we can see that benefits and drawbacks strongly co-occur with solution in issue description, while assumptions do not co-occur with architectural solutions. Finally, when looking at the decision factors, we find that assumptions actually co-occur with existing system quality, and thus developers assume things about existing system when explaining architecture when explaining the existing system in the issue description. This is maybe due to the complexity of systems. On the other hand, requirements co-occur with architectural solutions in issue description. When comparing the co-occurrences between architectural knowledge concepts in issue description and comments, we can notice the two differences. In issue description, requirements co-occur with solutions, while in comments, assumptions co-occur with the rational as well as existing system. This means that developers assume the benefits and drawbacks of solutions in issue comments to justify their decisions. These co-occurrences are useful for guiding architectural knowledge capturing approaches. For example, capturing both solution and rational from the same place, either from issue description or from the comments. Our last research question here is about how architectural knowledge concepts are represented in issues. We found that each architectural knowledge concept comes in certain textual variants. We will provide here an example for textual variants for a single architectural knowledge concept, which is the benefits and drawbacks. Benefits and drawbacks come in four different textual variants. The first variant is obvious. It's simply by explicitly mentioning the terms benefit or drawback or one of their synonyms such as advantages, disadvantages. The second textual variant is when using adjectives. For example, using adjective like good or bad or slow or ugly, and accordingly from this they could evaluate the architectural solutions. The third variant explains the quality of solution to express its benefit or drawback. For example, here developers discuss on performance of a database management system by mentioning the number of processed rows per second. The last variant for benefits and drawbacks is about expressing the problems or issues which happen in a certain architectural solution. For example, by expressing the bugs or missing features in a certain solution. Like the example here expressed that it does not support concurrency. These textual variants are useful for capturing architectural knowledge. An effective capturing approach should consider the different textual variants for each architectural knowledge concept. We wanted to explore architectural knowledge concepts in issue tracking systems. Accordingly, we provide a dataset of architectural issues and annotation on architectural knowledge concepts. Moreover, we provide an analysis on these annotations to determine the most important characteristics of architectural knowledge concepts in architectural issues. Our future work is concerned with expanding this dataset with additional architectural issues and also expanding our annotations with further textual variants on architectural knowledge concepts. Moreover, we would like to explore other methods for finding architectural issues and evaluating them, such as top-down approaches. Finally, we are interested to propose approaches for capturing architectural knowledge using these datasets as training dataset for machine learning approaches. With this, I conclude the presentation. Thank you for your listening.